So we start with the green chemistry once again. So some incident that you need to know why this green chemistry is required to know. So from some certain data, some case studies, you will understand better. From see, this is a river. Accumulation of so much of chemical happened there, it caught fire by itself without any sort of provocation. It caught fire automatically because of accumulation of chemical. That is one incident. Lot of incident, accident. So what is the problem of chemicals that people need to know? This is the problem of chemical. Dumping chemical into a river over a period of time, so many chemicals accumulate in such a way, it really exploded. Reaction happened. This is quite bad. Bhopal gas tragedy. What was the gas? Methyl isocyanate gas. MIC. Methyl isocyanate. Okay. So this methyl isocyanate gas is a precursor of carbaryl, which is a pesticide. So this was stored into a tank, and somehow the cooling system failed, and in the midnight the leakage was there and gas came out, and the whole area affected by the gas leakage. So many people died, so many people become crippled and so on. So that is the Bhopal gas disaster. He is called the father of green chemistry. First proposed about the green chemistry. Now, green chemistry is designed to chemical products and process that reduce or eliminate the use or generation of hazardous or toxic chemicals. You have to arrange in such a way that that thought process you have to change in a way so that the prevention or use of toxic chemicals and different type of toxic solvents, waste minimization. So these 12 principles already have started. So these are the things. So using non-toxic reagents and so on. Using renewable feedstock instead of non-renewable one. So these are the total. But one by one we will go into detail. So first of all, prevention of waste. Prevention of waste in the chemical process industry, as far as possible, the waste formation should be prevented. So we have to plan in such a way there will be no waste. So here you see forming lot of waste, here there is no waste. So we have to go for a no waste, zero tolerant system. We are not tolerant to any toxic material. We are not tolerant to any waste material. That is the policy. That is the policy at least. Next is atom economy. The percent atom economy equal to molecular weight of. Hey, why you are not listening? এদিকে দেখো, এই কি করছো? কি পড়ছো? বন্ধ করো। এদিকে দেখো। যেটা পড়াচ্ছি সেটা পড়ো। Atom economy, what is this? Percent atom economy, molecular weight of desired product by molecular weight of all reactants into 100. You have got different reactants. After reaction, you are getting some desired product. So the weight of desired product by weight of all the reactants concerned into 100. That is giving you the atom economy. So the higher the percentage of the molecular weight of desired product, better is the atom economy. Okay. So if you are getting more than 90%, it's very good. Atom economy. So some common reactions, rearrangement reaction, addition reaction. So here the atom economy is 100%. The number of molecules you are taking here, the number of molecules you are taking here will be same. So this type of reaction, rearrangement reaction, addition reaction, these are because the product that you are getting, nothing will be wasted. There is no waste material produced at all. Diels-Alder reaction. Have you heard about Diels-Alder reaction? So Diels-Alder reaction, I can give one example to make you understand. At a certain height, you are getting what is this? এটা কি বলো? হ্যাঁ? বুঝতে পারছো না? 1,3-butadiene। আর এটা কি? এটা কি? কেউ চিনতে পারছো না? অ্যাসিটিলিন। এটা টিভি বলতে অ্যাসিটিলিন। After that, what you get, this is called Diels-Alder reaction. Cyclization. Diels-Alder reaction, cyclization. And how did it happen? Arrow. Got it? Cyclization. Ring formation. This type of reaction will be 100%. There is no, other than the desired product, nothing else is formed. You don't get anything else. This type of reaction you have to choose, where the product will be 100% formed from the reactant. Totally gaseous phase reactions. No solvent required, no nuisance, no waste materials. Isn't it good? So this type of reaction you have to do. Some little bit of catalyst sometimes will be required. Well, that can be there. So this one, Iriarimi reaction. This sort of reaction. Another one, from my mind I have shown you. That is called Diels-Alder. 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 Scientist, name of the scientist, name reaction. Oh, this is ethene. Oh, this one. Oh, I have taken acetylene, here it is taken ethene. Same thing. This is also Diels-Alder. Butadiene plus ethene they have taken. I have taken acetylene. So if you take acetylene, one double bond will be there, and if you are taking ethene, then there will be no double bond. That's the difference. So that's why one double bond. In my case, it was two double bonds. Ethyl propionate plus methylamine. You are getting two products. One is the desired product, one is the side product. But this side product you have to collect and utilize. These are the principles. So principles already I have discussed, so I can skip. Use of some practical example that is there in this slide. It was not there. That's why I have opened this. So bisphenol A plus phosgene, you are getting polycarbonate. This is one reaction. What you are using? Phosgene, which is highly hazardous. This phosgene. This is a conventional method. Okay, this is a conventional method, formation of polycarbonate. Why don't you go by alternative method? Instead of this phosgene, if you are using this solid state polymerization, this thing, then you are getting polycarbonate. You are getting polycarbonate without any side product. And also, you are not using any hazardous chemical. Phosgene, when you are using as a raw material, you are creating pollution somehow or the other. Some leakage, some spillage will be there. So toxic chemical use should be prevented. Instead of using the toxic chemical, this is a solid state material. So, and you are getting polycarbonate. This is solid. This is solid. This is liquid, but this is solid. Solid phase polymerization. This and this will give solidify. And nothing is produced as a side product. No waste, zero waste technique. Some of the zero waste technique I am showing. These are zero waste technique. Possible. It's not that impossible. Alternative route you have to find. Just find it out. And people are finding. This also safer solvent, designing safer chemicals I have discussed already. So, safer dry cleaning. How do you do the dry cleaning? কোটে ময়লা লেগে গেছে, কি করে ক্লিন করব? ইয়েতে দিতে হবে, তাই না? ড্রাই ক্লিনিং এর দোকানে দিতে হবে. So how do you doing some magic stick and doing it? ম্যাজিক ওয়াইট ঘুরিয়ে দিচ্ছে. How do you doing that clean? সাবান ইউজ করা চলবে না, তাহলে নষ্ট হয়ে যাবে. তাহলে how they are doing that? We cannot do it at home because we cannot use soap. Then what we are using? What people are using? Petrol. You should have idea. Don't talk. Listen. খালি গল্প করে গেলে হবে? শোনো, গল্প করে বাড়ি চলে যাবে, কিছু তো শুনে যাও. How we are doing the cleaning? At home we are using detergent, soap, etc. So in the dry cleaning agent, that soap, how the shopkeeper, they are sending somewhere, so what they are doing, how they are cleaning the coat, the very costly sari, so they, how they are doing cleaning? Petrol. They are using petrol. They are taking petrol into that cotton balls and that soak it like this and clean it. Only the spots they are cleaning, not the as a whole. They are not taking petrol and put the whole thing into this. Not like that. Taking petrol into some small container, white petrol, not this petrol. This petrol may release some stain. উল্টে দাগ হয়ে যেতে পারে, এই পেট্রোলে তো কালার মেশানো আছে। হোয়াইট পেট্রোল is to use. That's why very costly petrol. You cannot get it in the market, open market. So this white petrol they will take, totally colorless liquid like water. They're using that cotton balls and then just scrubbing with that particular stain, যেখানে যেখানে দাগ আছে বা ময়লা আছে, ডার্ট আছে, উঠে যাবে। So they are doing that. Okay. Now instead of that, if you use liquid carbon dioxide, is a very good one, because ultimately it's a gas, so it will automatically evaporate and it will leave no stain, nothing. Sob dhue chale jabe. First it is liquid, so we are using it. After cleaning, just keep it open here, it will be dry, and within a few minutes it will be totally clean. So carbon dioxide is very good dry cleaning agent. Lead pollution has been decreased by, instead of tetraethyl or tetramethyl lead compounds are not desirable. If you use ethyl tertiary butyl ether or methyl tertiary butyl ether, this type of things if you use into just to increase the octane number. Octane number শিখে গেছো এখন? So if you are using this methyl tertiary butyl ether or ethyl tertiary butyl ether, these are highly branched compound. That's why the knocking problem will be overcome and you will get the higher octane number value. So that you can remove. Instead of using some lead material, this type of chemical we can use, which is totally toxic free. Design of energy efficiency, use of proper catalyst, enzyme, microorganisms, this type of things should be used. Example, those examples are not there in the earlier slide, that's why I opened this. See, lot of example there, you will understand better. You have a glucose, E. coli is a bacteria. From E. coli bacteria is converting this into ultimately into this by the steps, getting adipic acid. So last you are getting cis muconic acid and platinum hydrogen 50 psi. Okay, so what you are getting? Adipic acid. So what was our objective? To get adipic acid, and instead of adipic acid is required for nylon production. So that adipic acid you initially conventional was from benzene. So better you can use some this bacteria and do the job. So in this case the advantage is a lot, because benzene is highly carcinogenic material, so, and this is coming from petroleum. So this benzene is also some it is coming from coal tar. Do you know the source of benzene? It is from coal tar. And what is coal? It is also it is a non-renewable resource. So coal is also not good. Coal petrol you have to slowly drop. The idea of using coal and petrol you have to drop. So what to do then? So alternative, bacterial method. Even nowadays you may be knowing, I don't know whether you know it or not, hematite, from hematite iron production, how we are doing? Blast furnace. It is high temperature, high pressure and all these things. So that can be avoided by using bacteria. Some bacteria they by leaching they can produce iron from iron oxide. Isn't it good? Okay, so that type of method is also has come already. It is that ferric oxide or ferric hydroxide as well as ferric this type of compound, so they can leach around and ultimately produce iron out of that. So polylactic acid for plastic production, starting from corn collect the starch from corn starch. Corn starch তো আমরা বাড়িতে ইউজ করি, কি বলে এটাকে, পাউডার, কর্নফ্লোর। সেই কর্নফ্লোর থেকে ধরো শুরু করছো, ইউ আর স্টার্টিং ফ্রম কর্নফ্লোর, ওকে, corn to cornflour, then unrefined dextrose, then fermentation, it undergoes fermentation, then lactic acid monomer production, that is the lactic acid. Lactic acid is the monomer that is produced by fermentation. Lactic acid is produced by fermentation, and after that lactide polymer production, that is the lactide, then polylactic acid, PLA, then polymer modification, and after that by processing you are getting different type of polylactic acid. Achha, have you seen the carry bag, plastic carry bag nowadays? Earlier it was polythene, nowadays have you seen recent one? দেখেছো একটু অন্যরকম দেখতে, একটু নরম নরম টাইপের, দ্যাট ইজ পলিল্যাকটিক অ্যাসিড। পলিল্যাকটিক অ্যাসিড ব্যাগ, instead of polythene bag, people are using polylactic acid bag. Benefit, it is biodegradable. It is biodegradable, totally biodegradable, produced from starch. This is the way how to make it. Total method is given. Reduce derivatives means side products. Catalyst, reaction makes the reaction faster, decrease the energy requirement, minimize the waste. So catalyst, use of catalyst is always encouraged. People are encouraging, okay, you have to use more and more catalyst as and whenever possible. And which type of catalyst? Biocatalyst. Instead of chemical catalyst, go for biocatalyst. Earlier days people used to use chromium, nickel as catalyst and all, but instead of that, if you go for biocatalyst, is far better. Why? Because biocatalyst gives much more specific product. Instead of lot of different products, it is giving very specific products. So separation problem is also over. Only disadvantage is that bacteria is usually slow, but it works at a very low temperature, ranges usually between 30 to 40 to maximum 50. In that range it will work, and that is the advantage. So you don't have to use any costly fuel, don't have to give a high temperature process, high pressure processing industry. All these things are not required. So initial investment will become much less. A small container will do. Okay, you don't have to go for a very huge one. Bacteria cannot work in a very huge setup. You have to make small setup and use in a parallel way. Separate, small container, and club them together, make it huge. Degrading products, polythene, polystyrene, not biodegradable, but biodegradable polymer. Nowadays biodegradable polymer are more used, is coming in the market. This polylactic acid, as an example, I have some sample with me. Okay, polylactic acid bags. So nowadays people are using paper bags and polylactic acid bags. Supply is a bit limited, that's why people are using paper bag also. If you give some order, now they will give you supply into paper bags nowadays instead of polythene bags. Polythene bags totally removed from the market. So these methods already have sales. Now coming to this is one of the efficiency parameter, reaction yield, percent yield, actual yield by theoretical yield to 100. That is called reaction yield. Yield means production. Atom economy, percent atom economy, molecular weight of desired product by molecular weight of all reactants into 100. That is called atom economy, percent atom economy. So here the atom economy is very good, 100%. The amount of product formed and amount of reactant used are equal. Diels-Alder reaction is like that, 100% efficiency. 100% efficiency. So many examples I am showing you where 100% efficiency is there. Conversion, amount of reactant taken minus amount of reactant unconsumed by amount of reactant taken, or amount of reactant reacted by amount of reactant taken into 100. Reaction selectivity, amount of desired product divided by amount of expected product into 100. environmental load factor, total mass of effluent generated by number of mass of desired product into 100. How much pollution you are creating, that also you can account for. How much pollution, effluent is pollution, so how much polluting material you are producing, you can have some accountability by calculation. Percentage, you have to give the report to the government that actually how much pollution you are producing, and accordingly you have to give the tax. More the pollution, more will be the tax. So that's why, and that is the policy now. That's why industry will have to go for minimization of pollution. Otherwise, they will have to pay more tax. Okay, and that tax will be spent for society. That is the policy. Now, after that, what is happening? No, you know the. But theoretically, it is supposed to be like this. The more the pollution, more they pay the tax, and it will be used for the benefit of the society, for some way or the other, making road and all these things.
A science revolution in green chemistry, launched 20 years ago, is paving the way to a sustainable world that supports a healthy and vibrant economy. The science builds on great achievements by chemists and chemical engineers.
For 150 years or more, chemists have been finding out ways to put together new molecules. And they've done it in a way that achieves astounding things.
Modern chemistry has improved our lives, provided an amazing array of consumer products, put food on our table, and saved lives with new medicines. Yet many of these achievements have come with a price.
Lastly, I can tell you, we are going back in our previous ways. Earlier, what